Hello everyone, today we are going to draw a 2-input NAND gate and a 2-input AND gate. First we will draw a 2-input NAND gate, then if we just draw an inverter to the output of a 2-input NAND gate, then we will get the 2-input AND gate. To draw the 2-input NAND gate, we will give 2 PMOS in the pull-up network in parallel and then 2 NMOS in the pull-down network in series. And then we will just give VDD and ground. So let's go to DSCH2 software and draw the 2-input NAND gate first. To draw the NAND gate, we will draw 2 PMOS in the pull-up network in parallel and 2 NMOS in series in the pull-down network. That's what I'm doing here. Let's zoom in a bit. Let's move it a bit. Now I'm connecting the wires. Now I will give supply to the pull-up network and ground to the pull-down network. Now I will just give input. Let's give 2 input here. This PMOS corresponding NMOS is this one, so the same input will go to this PMOS and this NMOS, and same input will go to this PMOS and this NMOS. So let's give input to here and give input to here. If you want, you can also change the name. Let's change it to B. Now we have to give the input to the 2 PMOS. Yes, we can see that our NAND gate is completed. Now we will just give output to see the output. So here's our final NAND gate. So now let's check if it is working properly. From the truth table of NAND gate, we see that for only if both the inputs are high, then only we can get the output low. Otherwise, for all the cases, if any of the inputs are low or 0, then the output will be high. So let's give both of the inputs as high and let's see if the output comes low. Now let's run the simulation. Now let's give high to both the inputs. To give high to both the inputs, we will have to give red to both of these buttons. Just click on this one and click on this one. We see that the light has turned off. It means that we have got a low output according to the truth table. Now let's turn off any one of this, and we see that we can get a 1 or a high voltage. Now turn on this one and let's turn off this one. So we can see for 1-0 combination, we are getting a 1 combination, which is corresponding to this one. For any of the low inputs, we are getting a high output. And if both of the inputs are high, then we can get a low output. Now let's turn off the simulation, and now let's draw a 2-input AND gate. To draw a 2-input AND gate, we'll just have to add an inverter to the output of this NAND gate. First, we have to delete this LED light. To delete, we have to click on this one and click on this one. It will get deleted. To give the inverter, we can add an inverter in this way using 1 PMOS and NMOS to the output of the NAND gate. Or we can simply use a inverter from here directly. Now let's add a output here. Let's join it. Now our 2-input AND gate is completed. Let's check if it is working properly. From the truth table of AND gate, we can see if both of the outputs are high, or if both of the inputs are high, then we will get a high voltage in the output. If any one of the inputs are low, then we will get a low voltage. So let's see it here. First, let's turn on the simulation. First, let's give both of the input as high. We can see giving both of the inputs as high, we got also a high output in the here. Now let's give low input to any of this. Here we can see if we give 0, 1, we can see the output as 0. Now let's give 0, 1, 0. We can see for giving 1, 0 output, we got a 0 output. Now let's give both of the inputs as 0. Here we can see also both of the inputs are 0 and we got a 0 output. But if we give both of the inputs as 1, we can get the output as 1. So here you can see that our both NAND gate work properly, and then after we added our inverter, our AND gate is working also properly. Thank you for watching. That's it for now.